All right. Let's see. I don't see anyone else waiting to be admitted. I'll keep pushing the button. Welcome everyone to the kickoff for the BEAD Core seminar, winter seminar series. My name's Laura Pritchett. I'm Administrative Director of the BEAD Core. I know Jackie Jennings is also here somewhere. She's the director of the BEAD Core, but she's traveling right now. So it's my honor to introduce Bahareh Modanloo, who is a senior research business analyst with us, business intelligence analyst with us. Her background is in data science, and she is our BEAD Core resident expert on machine learning. And she also does our work with Epic extractions and has spearheaded our work with the Precision Medicine Analytics Platform and the Precision Medicine Centers of Excellence. Her degree in computer science is from the Rochester Institute of Technology, and she's been with us now for a couple of years, right, Bahareh? And so I will not take any more of the time. We've got a lot of really interesting things to talk about. Just one quick plug: if you would like services from the BEAD Core, research support services, please just email beadcore@jhmi.edu, and we will send along a form so that you can submit an intake for services with us. Thank you all for coming, and Bahareh, take it away.
Hello, everyone, and thanks, Laura, for introducing me. So in the interest of time, because I have a lot to cover today, I'm going to start, if you agree. So I'm going to share my screen in the slide. Yeah. Okay.
Great, we can see it.
Yeah. So, okay. So yeah, today we are going to talk about the data wrangling and analysis using EPIC and PMCOE data, or some people call it PMCOE. I've heard both PMCOE and PMCOE, so I guess both are right. We are going to talk about the nuts and bolts of working with EPIC data and PMCOE's project. Before we go into the detail of it, let's look at some general characteristic of EPIC and PMCOE data. These two types of project both have some similarities. They both have big amount of data. There are many tables, dimensions, and elements in the data. There are many complex relationships between data element and tables, and only for PMCOEs or PMCOEs, there are different methods of data collection because they have different source of data. The data can come from different sources. It's not only EPIC in the PMCOEs data. And there are different data structures and formats, and data is stored in a different format and structures at the back end of EPIC or on the PMCOE's SQL Server databases. Because of those characteristics, extensive programming and data formatting are needed for these types of projects, and there is always a back and forth process. And because of these types of projects are more complicated and more time consuming. We're going to get to the more details of that. Why is that? And to explain all these characteristics one by one in more details with a real world example that I have worked with. But before we do that, let's talk about the terminology. One very important terminology of the PMCOE project. Whenever you see the word projection, that means your data, which is stored in a structured query language or SQL database. Why is that? Because your data is simply projected to a database, which is which is supported by SQL. So projection means SQL databases. You know, we don't want to make it too complicated for you. But you know, before we go to the detail of this, I think this is very helpful to see how and what a database SQL service looks like. Here you can see I put 3 screenshots of my SQL servers. On the left-hand side, you can see the environment of the SQL databases. As you can see, there are many projections. This is just a part of it. It's not all the projection in the SQL server. But I just wanted you to see that there are many projection or databases in a SQL server here. And if you click on one projection or one database, which is our example project that we are going to talk about it more. Here, I clicked on this projection. You are able, if you click on that, if you have access to it, and if you click on that, you're able to see more details of that specific projection. I clicked on the table part of it because I wanted to see how many tables there are in the projection. And as you can see, there are more than 40 tables. And if you click on one of the tables, which I did, I click on all encounters table, you can see there are more than 50 columns in there. And I wasn't able to show it to you, but there are millions and millions of records in each column. You know, this is an example for you to see when we say big data, what we are talking about exactly. We're going to talk about it in more detail later in the next slide. But before we do that, let's see what is the general process of a PMCOE project. In this flowchart, you can see the overall process. Let me talk about, put it here. As you can see in this flowchart, there are 6 steps, and usually, but not always, BEAD Core is involved at step 3. But in step 1, the study team requests data from the projection team, and in the step 2, projection team project the data into SQL server. At which step we are not involved, because at BEAD Core we are not authorized to do any projection, and we are not doing that. But step 3 is actually where our role and our job started. So at this step, a study team with their own database, because the database is already projected by the projection team, and so at this step, the study team already has a projection or database, and they already has a plan. They already have a database. They come to us and request data management and analysis, and after the initial consultation and discussion, we move forward to the step 4, where BEAD can start the investigations and exploration. Usually we do we do some different sort of investigation. We investigate the projection, including all tables and columns, in order to understand the relationship between tables, between columns, between different variables that you want to include in your analysis. We investigate the study team inclusion criteria to make sure that all the elements in your criteria are already there. We investigate the needed data element and the variables, and if they need to filter some specific patients or encounter or anything, we investigate their filtering requirements. And more importantly, we do a lot of we call it EDA or exploratory data analysis at this stage. And they are simply there are different sorts of summary tables, data visualization, different graphs, different figures, in order to understand what is going on in the data. As you can see, step 4 is a very important step, and it's time consuming. It takes a lot of effort and data wrangling, data visualization. But at this stage, after the initial investigation and exploration, we realize that whether we need more data or whether we have actually all the needed data and elements in our projection or not. Per my experience, most of the time, actually in my experience, all of the projects I have worked with, the answers were no. But I'm sure there are cases that the answers are yes. So per my experience, most of the time the answer is no, actually, at least for the first time that we investigate the data. So there is a huge possibility that we need more elements, that some of the elements and variables are missing, and we need to go back to the step one. And we need to inform the investigators of the missing element, and they need to go back to the projection team and ask them for the needed data element to be added, and the projection team will update the projection, and then we are at step 4 again. As you can see, I put it here. This is a back and forth process. And when I said there is a back and forth process, here is the back and forth process that I earlier mentioned. So you may ask yourself, and that we are in step 4 again, and we continue our investigation, and later we may realize that, oh, there are more missing data, there are more data issues, and we need to go back to the projection team again and again and again. So you may ask yourself why we are not doing this one time in one cycle. So the answer to this question is because of the nature of this type of project, or maybe because of the nature of research, or the type of the study they're conducting. That cannot be happening in one cycle. I'm not saying it cannot happen in one cycle all the time, but it's possible that the cycle could be repeated multiple times, because if those missing element or variable are part of your inclusion criteria, we cannot even identify the cohort, so we can't continue with that, and we have to wait until those criteria is added to the database, and then we can keep continuing our investigation. And during that continuation, we realize more elements are needed, or we realize more data issue. So it says that we are stuck at some point because of some needed element, and we can't continue to the end to investigate all the thing that is needed. So that's why you are seeing this back and forth process as an iterative process. So finally, at step 4, when we have everything, we move forward to the step 5, and at this step, we actually do data extraction, wrangling to create the analytical data set. And even at this step, it's possible that we may need to go to the step 1 for adding more elements or for updating the projection. I'm gonna explain it in more detail why, but when we go to talk about one real example, and you understand what I mean better. But yeah, at this step, there is possibility for going to the back and forth process, and go to the step 1, step 4, and step 5 again, and repeat that multiple times. Anyway, finally, when we are done on step 5, and the answer to this question, that do we have all the needed data and variables, is yes, we can proceed to the step 6, which is conducting data analysis. So let's look at one real example, step by step, with real case examples, and you understand the whole process better. We are going to start at step 3 because, as I mentioned, this is where BEAD Core usually involves. So the project that we are going to look at together is called Adult Primary Care Center of Excellence, and they already had a projection with big amount of data, including 40 tables, 1,485 columns, and each table had millions and millions of records, which I show you later when we get to the point of big data. I'll explain it more. What we did at this stage, we finalized their analysis plan, the inclusion criteria, and the list of the data elements. And their inclusion criteria consist of patients who had a patient visit on or after some specific date. They at some specific clinic with some specific specialty that you can see on the screen. They should have the outpatient, their outpatient visit status should be completed, and with visit having some specific CPT code, that those CPT codes were identified by investigators. We later used that CPT code to identify in-person versus virtual visit, which was needed as part of the analysis. They asked for 38 data elements, and their analytical data set needed to be summarized by provider per year per month. We moved forward to the step 4. We started the investigation. We investigated the data and did a lot of data exploratory to see if they have the right data and they have all the elements they need for in their projection or not. And we realized that the CPT code that the type of CPT code that were stored in the projection were not actually stored in the right format. The CPT code didn't have the modifier, which was required to distinguish between in-person and virtual visit. So at this stage, we had to go back to the step 1. Actually, we informed the investigator about the issue. They had to ask the projection team for the CPT modifier to be added. And then they are at step 1. So you can see the back and forth process with me right now. So the projection was updated with an additional table having CPT code along with the modifier. And as far as I remember, it took a few weeks. And then after the projection got updated, we were at step 4 again. We continued our investigation. We investigated the new data added, the new tables, and unfortunately found other issues. And these issues cannot be found earlier because as I explained earlier, we couldn't actually move forward or continue, and we were stuck at some point. So later we found that they had tables from different schema in the projection. They had PHI schema tables and non-PHI schema tables, and neither patient IDs or encounter IDs from PHI schema tables matched with the other schema tables. And the reason was that the PHI tables had the real IDs, while the non-PHI tables had the masked IDs. And the reason that the non-PHI table had the masked ID is to protect the patient identity, which is a usual case, in the clinical data analysis. So these two types of IDs didn't match, and we couldn't match and join the PHI tables with the non-PHI tables, which was required to create the analytical data set. The CPT codes were stored in a PHI table, and we needed to map them to the other encounter level table using encounter IDs. So we went back to the step 1 again, and we informed the investigator about this issue, and they went to the projection team again to fix it. And they corrected that, and the IDs finally matched for all the tables. And in step 4 again, we did all the required data exploration, and we finally realized that we can move forward to step 5. And here we are at step 5. We're going to stay at step 5 a little longer because step 4 and step 5 alone themselves are a very time-consuming stage because they require extensive programming, wrangling, formatting, and they are not an easy and quick steps to be completed. So, regardless of how many time we need to go through the back and forth process, these 2 steps alone are time consuming. So that's why I wanted to give more details during step 4 and step 5 in order to illustrate the complexity of these 2, the complexity and the importance of these 2 steps. So in step 5, we finally started data cleaning and wrangling, and but at this step we needed to confirm with PI how to clean and format some variable because we saw some unexpected data values and type. Not all the visit with the given CPT code could be classified under in-person or virtual classes because there were some visit having some modifiers that we haven't been given. That usually we were told to look at the modifier GT or 95 modifiers and classify them, but we saw other modifier in the data that we weren't expected to see those. So we put the visit with those unexpected modifier under the class of null and ask the PI to let us know how we should process with those kind of unexpected issues. We needed to know what to do with those visits and how to format them. So we asked the PI the possible questions: should we remove them from data, or should we keep them under null classes, or should we classify them as a new class that they wanted to have in their data. And they got back to us and said that all the extra modifiers should be in-person visits. After this stage, we created an initial analysis data set based on their inclusion criteria, but we unexpectedly saw data. The data were only for 12 out of 45 clinics. This was really unexpected, and we checked the database for the 45 departments and PMCOEs or PMAP are clinics. One of the other naming convention is when we say departments, and that usually that means clinics. So we checked the database for the 45 clinics names against their inclusion criteria, and find out that 2 of their inclusion criteria, including the admission class of outpatient and the given CPT code, were limiting the department down to 12. So we realized one of the inclusion criteria defined as admission class of outpatient was actually a redundant one, because the given CPT code and the clinic names were we're already including the outpatient clinic. So having this extra filter was actually not necessary and redundant, and because of that redundant filter, we would miss a lot of needed data. So we removed this filter in order to recapture the rest of the clinic, and this problem got solved. We are still at step 5. After updating the analytical data set, the PI realized that the numbers, patient numbers and encounter numbers, were still too low. And here it is, we are again at the step 5. And this is the when I say at step 5, there are still possibilities that we can go through the back and forth process. So after step 5, we realized that the numbers are still too low, and now we are in step 5 again, because we already checked and corrected the inclusion criteria. We knew that low number couldn't come from the inclusion criteria. So they decided to troubleshoot this with some clinic manager to talk about the way that they collected data, and they talked to the projection team about the way they actually project the data. And after 1.5 months, they got back to us and said that the projection was fixed. So we could continue working at this step. So we were back at step 5 again, and we continued working on data cleaning and wrangling and formatting to create the analytical data set. But not all the requested variables were available in the database. So we had to create and format some of those variables, and in order to create and format them, we needed to we needed more time, and we needed actually the confirmation from PI about how to clean and format them, which I'm going to explain more later. So here are some examples. One example is, since there was no direct element to indicate if a visit was virtual or in person, we actually needed to create that out of the CPT code. So we use the CPT code and the related modifier to create a variable indicating if a visit was virtual or in person. The other thing is they asked for 36 variables in their analytical data set, which all of those variables were summarized per provider, per year, per month, the variable available in the data set were not summarized. So we needed to create and format those summarized variables. I put some example here. I'm not going to read all of that, maybe the first two. So they needed Black patient proportion per provider, per year, per month, and we created this variable from the available variable of race, provider, and contact date. Or the other example is they needed patient proportion in most deprived category by census tract, per provider, per year, per month, and this variable wasn't available, so we had to create that out of the ADI, or area deprivation index, variable, provider, and contact date. So these are just an example for you to understand. Sometimes the variable you want to include in your analysis is not available, but other variables are available, and we can use those other variables to create your variable. They even asked for adding more data element later. They asked for adding more data element to the analytical data set, and adding those extra element needed confirmation with the PI for how to clean and how to format that. They asked for adding 1 clinic per provider per year per month, while it couldn't be done easily without further instructions. Because many providers had more than, many providers had more than 1 clinic per month, we couldn't simply just pick 1 clinic out of many. So we didn't know how to summarize many clinics per provider per month, while, as I mentioned, all the variables needed to be summarized. So we raised this issue to the study team, and they got back to us and they said that they want each provider linked to only 1 clinic per month at the clinic where they saw the most patients. This took a bit longer for us to create that, since we needed to calculate the number of patients per provider per month per clinic first, and then pick the clinic having the maximum number of patients for each provider per month. This required us to write a separate SQL script for that, to create a separate table for them, and then join that table to the summarized analytical data set based on the provider per month. I explained a little bit about the difficulty and complexity of data wrangling and creating variables, and now I want to talk a little bit about the big amount of data they had. This database has a big amount of data, as I said earlier, with more than 40 tables and about 1,485 columns. And as you can see, there are millions and millions of records for the different types of data. For example, they had 134 million records for only lab results, or they had 257 million records for their medication. And you can see the number on the screen, and imagine how big this amount of data could get when the tables are merged together, which is needed as part of the job, because we are not going to use only 1 table. Usually when we create analytical data set, we are merging multiple tables. And you can imagine how this number gets multiplied by each other and what we mean by big amount of data. So this big amount of data made coding and debugging more complex. Running codes, testing, and debugging took way more time than we expected. Each time the code was changed, it took a few hours to run and return the result, and which was a little bit, difficult when some error happened and we wanted to debug the code to see where that error is coming from. So I wanted to actually put this information for you to see, when we say big data, how big we are talking about actually. We are still at step 5. We updated the final analytical data set and gave them the final version. And this process from start to finalize the analytical data set took 5 months. And finally, we are at the last step, step 6, which is data analysis. I'm explaining what we did for the analysis a little bit. So the outcome of their interests were institutional healthcare effectiveness data and information set quality measures for each physician by month. So we used generalized linear mixed model that included patient demographics, physicians' annual counts of visit, a COVID risk indicator per month, and a rural or urban clinic indicator. The model included random intercept for physicians and clinic. So, regardless of what type of PMCOE project we are working on, there are some, there are some general rules when it comes to PMCOE or PMAP project. Those rules are, as you see in the specific example, during step 4 and step 5, and after investigations and exploration, we realize whether we have all the required data or we miss some of them. And in this case, we need to go back to the projection team and ask for needed data elements, for more data element to be added. There are some other common scenarios rather than the one that I already explained within our specific example. So those common scenarios are, one common scenario is more data elements are needed. So why we need more data elements? That could be due to some reason. For example, some of the current elements in the projection are not useful anymore and they need to be changed into another set of elements. One example could be diagnosis table was only for discharge diagnosis while admission diagnoses were needed, or vice versa. Or the other scenario is new type of data elements are needed to be added to the projection. The examples could be diagnosis table didn't have the primary diagnosis element, and this element needed to be added to the diagnosis table. Another example is an additional table. This is exactly the example that you saw, that the CPT code need to be updated with an additional table in order to have all the information we needed. Some other scenarios are, some unexpected data that could be patients, encounter, provider are found, or some expected data are missed. This could be due to the following reason. Inclusion criteria are not detailed enough and there should be more filters, so a study team needs to review the inclusion criteria. Here are some examples. Adding and removing a procedure code or diagnosis code to include or exclude data. The other example is being more specific about different location or different clinics in terms of their names, their IDs, their specialties. The other reason is the methods of data collection could have some data entry error. Some examples are because we have seen pregnant patients with 2 delivery types for one non-twin pregnancy. That we saw those types of error in the projection. Or another example could be the number of patient or encounters included were too low. Or there could be some error during the projection process. When the projection team actually projected the data, there could be some provider that hasn't been captured in the projection, pregnant patient with the wrong delivery types, or some linkage issue with the IDs, or having wrong type of encounters or admission in the projection. Those all could be happening. So, in general, just because there is a projection, that doesn't mean it is ready for analysis. An analytical data set needs to be built out of a projection, which takes time. Always expect some data issues such as unexpected data types, data values, duplicate, unexpected lab result, unexpected medication, unexpected diagnosis in your database. When facing those unexpected issues, we need to confirm with PIs how to deal with them. Here are some, because if we are going to clean, filter, or format data, we need confirmation first because we don't want to do it in a wrong way. So here are some possible questions that we ask from PI Should we remove unexpected data, or should we merge them into existing group, or should we put them under a new group? Just always bear in mind that this confirmation may take time. In step one, so there are some way, or there is a solution that you can use to eliminate or at least shorten the back and forth process. In step one, when a study team asks for data from projection team, if a study team has a detailed and clear plan of their inclusion criteria, if they know exactly what are their needed data element and what kind of analysis they want to conduct with their details, there is a chance that the back and forth process could be eliminated or at least shortened to fewer tasks or iteration. In step 4 and 5, which I said that are a very time-consuming step, these are actually the most significant steps and the most time-consuming steps. And these steps cannot be done very fast, as this step require investigation, a lot of data exploration, and those all require extensive programming, in order to be able to perform data wrangling and formatting. Always consider that sometimes running a script can take hours, given the size of the data. Finally, step 6 actually depends on the type of analysis that the study team is interested in. So it could be a very simple data analysis to a very complex analysis, like different type of machine learning modeling or techniques. It actually depends on the type of the analysis. So at this point, all I talked about was PMCOE and PMAP project. We haven't started to talk about the direct epic extraction, which I'm going to talk about. At this slide, you would see the general process of an epic extraction. I'm not going to, because in the interest of time, I'm not going to go through all these steps using one example, but the process is kind of similar, not exactly, but there are some similarities, but I'm going to explain it to you. Hopefully it is sensible and clear. So in epic extraction, unlike the PMAP or PMCOE's project, we are involved at the step 1 because there is no data projection in this step, and we are going to extract data from the very beginning for the study team. So at the step 1, as you can see here, a study team requests data from BEAD. And step 2 is kind of similar to the step 4 in PMCOEs. BEAD start investigating the backend of EPIC databases to locate all the tables and columns and elements. We investigate their inclusion criteria in order to make sure that all the inclusion criteria is available at the backend of EPIC. We investigate their needed data element to make sure they are right, and we investigate their needed filtering in order to make sure we have all the element needed to filter the data. And we also conduct exploratory data analysis involving multiple summary tables, different figures, different data visualization in order to make sure that everything is in a way that needed to be. After step 2, during step 2, we realized whether we need more information to look at all the needed data and elements from the study team or not. Sometimes the answer to this question is yes, sometimes it's no. If we need more information to look at all the elements on the back end of EPIC, we go to the step 3 and ask the study team to give us more information, and the they can provide us with the information, and then we are at step 2 again to continue our investigation. If what we need is part of the, as I already mentioned, if what we need is part of the inclusion criteria or part of the critical data element that we cannot continue, we have to wait until they get back to us and give us more information so we can continue. And yes, it's possible during that continuation, we realize that there are still more information needed from them, and this process can be repeated again. So after we got everything and we made sure that we investigate and we explored everything required, we need to answer one more question. This is a very important question. Are all the needed data and variables are stored discretely in EPIC? Because one important fact is, just because clinicians and people working at the front end of EPIC or at the patient chart, just because they see some field at the front end, that doesn't mean that field is stored discretely in EPIC. If there are possibilities that some of the fields are stored in the form of texts or messages in a non-discrete EPIC databases, which require some other techniques. It's called NLP. We are not going to talk about that, but it is very important for you to know that not all the available data in EPIC are stored discretely in SQL EPIC databases. So if all the needed data elements, if the answer to this question is no, and not all the data elements are not discretely stored, there are two possible scenarios. If that data is part of inclusion criteria, and we require that to identify the cohort, the extraction can't be done from EPIC. But if that data is part of the other data element, that data element need to be excluded from the EPIC extraction. But if the answer to the question is yes, if we have all the data discretely stored at the back end of EPIC, we can continue working on the data extraction, data wrangling, and formatting, and create your data analysis. Please, and then after that, we go to the step 6 to do the analysis, or you may want to do your analysis yourself. It depends from one project to other project. It varies. So something to remember. During step 2 and after conducting investigations and explorations, we realized that if, as I mentioned, we would realize if we need more information. Some of those common example that, that I've seen during my work is, we need to go back to the study team and ask for more info. And some common example could be, we need some MRNs and name of patient who meet the inclusion criteria. We need screenshots of their clinics of interest, the screenshot of the ID and name of the clinics of interest. We may need the date for the admission or contact or inpatient encounters, and we may need the screenshot of some field of interest that they can see at the EPICS patient chart. Some other things that are worth mentioning is step 2 and step 5 are same as step 4 and step 5 in the PMAP or PMCOE's project. Step 2 and step 5, because they involve a lot of investigation, data wrangling, data formatting, extensive programming. Step 2 and step 5 are alone a time-consuming step, regardless of a back and forth process. So they cannot be done really quickly. They are time-consuming, and this is something that you need to consider that. And yeah, similar to the step 6 at PMCOEs, step 6 data analysis really depends on the type of analysis the study team is interested in. It can take from simple analysis to very complex analysis, like machine learning and deep learning analysis. So here's I really wanted to talk about some limitation of EPIC extractions. So the EPIC extraction, the direct EPIC extraction is not always efficient and good, and it is something that you need to consider, that the output data in EPIC extraction is in the form of flat file. It's not in the form of SQL databases, because here at BEAD Core, we are not authorized to generate data projection in the form of databases, and the process of projecting data from EPIC to databases can be done through the CCDA. So EPIC extraction works well if the amount of needed data and elements are not too big. And EPIC extraction also works well if the level of data complexity is not too high. So always consider PMCOE if the amount of data is big and the output can be saved as a flat file. Always consider PMCOE if there is a need for having and maintaining databases. Always consider PMCOEs if there are many data elements and variables involved in your study. If there are complex relationships between your elements, if there are needs for complex filtering, if the output data need to be into many tables and having many relationships from one table to another tables, and if data source is not only EPIC and there are multiple data sources, always consider PMCOE. Why we recommend that? Because direct EPIC extraction from EPIC doesn't work efficiently if requested data is too complex. So for data with higher level of complexity, we strongly recommend to do your project under PMCOE platform. In PMCOE data projections, some elements and tables are curated and joined, which can save a lot of time when coding for later data wrangling and formatting. So just one thing, imagine the project, the example project that we went through step by step, and remember it took about 5 months. Imagine if that project were going through the direct EPIC extraction. It would take maybe it would take way more than 5 to 6 months. So always for the project involving big amount of data and the more complex project, always consider PMCOE's route, and always consider EPIC extraction for a smaller project with a smaller number of variables involved. That can work efficiently if your project is not complex, it's not too complex, or if the amount of data is not big. So sorry about that. Yeah, I had to cover all of that. So if you have any questions, I'm here. I can stay longer if you, sorry about the time.
Thank you, Bahareh. That was great. Yeah, we do. There's a lively conversation going on in the chat. I don't know if you've had a chance to look, but we have a lot of PMAP people here who are sort of helping to clarify, where code can be shared and things like that. But you'll see Bill King did have a question about what kind of data wrangling steps and functions might be the best candidates for generalizable code.
Oh, so let me, because let me, so should we answer all of the question or?
I think there's been a lot of back and forth. Does anybody want to jump in?
So if you get, sorry about that. I actually, because I was focusing on my presentation, I actually didn't pay attention to the chat. So if you can put the question again in the chat, or if you feel free to unmute and answer the question, I can answer that.
Yeah, Bahareh, hi, this is Bill. Now my question was, are there parts of the data wrangling that you do as BEAD does that are more amenable to being generalizable across any PMCOE or anyone who's trying to deal with a lot of epic data? Or because I know, and I thank you, Josh, you've had some responses, and I know that can be changed on the variables, but I think the way we can really up our game as an institution is we kind of take some of the allow more DIY work of the kind of the cleansing and work that needs to be done before the analysis can begin. And I think the more we can have people doing that, I think, you could say, well, it works against BEAD's interest because you're a consulting shop, you get paid by the hour. But I think if the client has a set amount of money, you're going to be able to spend more time doing interesting work if they can do some of this cleansing or wrangling before they have a conversation with you, or after you've had your initial consultation with them. I'm just trying to think of ways how we can do that, because it seems like there's a lot of repetitive effort, and I know there's not going to be a perfect overlap with everything, but it's better to start with something that you may have to tweak a little bit, and then we can build a library, and then now we have a way to become much better as a research institution. So I'll shut up from there.
Yeah. Yeah. Thanks for bringing up such an interesting matter. Yeah. Something I can speak only from my own experience and my perspective. Something that really helps to reduce the amount of effort and time that we're spending on that back and forth process is, I realize when the study team usually go to us or to the projection team, when they talk about what they want to do, they are not, they could be as specific, they could be more specific about the data-wise. I'm just talking about data-wise. They are specific enough, when it comes to clinical matters, but something that really helps them, they can be data-wise more specific about the type of data element they want, the type of the format they want to have. Because I realized that when they go to usually they go to the projection team and they ask for the projection, and then after that they come to us, and because of that we need to go to the back and forth process. When they go to the projection team, if they ask for more specific data in a specific format, it's not possible for them to be 100% accurate, but if they are more clear about the type of data, the data structure they want to have, or the type of variable they want to have, the projection team, I'm sure, because I've seen from the projection team that they have done this, they can curate and they can do some part of wrangling in the first place before we start on the data wrangling, and they can, in this way, they can save us and also the study team a lot of time, because a lot of those data wrangling has been already done by the projection team because they were aware what to do. So, this is very important step. I always, if I am involved in the very in the first step, because usually we are not involved in the first step, but I've seen some cases that people come to us first, and together we went to the projection team. And I had the chance to talk to the projection team, because they talked to me, and we've been in several meetings. So I knew that what kind of data and that kind of format they are interested in. So we talked to the projection team in a little bit more details, and they were able to project their data into the database in a more usable format. Of course, even doing that, of course, I believe that back and forth process, could be shortened, but there is a rare chance that it could be eliminated, because that is a part of research. Because in the middle of research, they would realize that they are not interested in that specific variable anymore, and they need to look at some other variables that they didn't think about in the first place. So now they have to ask that. This is normal part of the research, and but yeah, this is something that I can think of. Just be as specific as they could in the very first place when they come to us, or when they go to the projection team, because using that accurate information, the projection team can build a very a more friendly database for us, with less amount of work for wrangling and formatting. Did I answer that question?
Great. Well, in the interest of respecting everybody's time, thank you so much for coming. This was, if Bahareh said she's willing to hang out if anyone has questions, but I just wanted to make sure we give everybody a chance to get back to your afternoon. And thank you all so much for coming. We really appreciate it. And remember, just reach out to beadcore@jhmi.edu if you would like to get more information about our services. Thank you. And thank you, Bahareh. That was wonderful. And we'll see if anyone hangs out.
Yeah, I'm gonna
feel free to jump in if you have questions.
Yeah, if you have any question, please feel free to unmute. I'm more than happy to answer any question.
All right. Oh, you got a lot of thanks in the chat. That's very nice. All right. Well, I guess everybody, I don't see anybody piping up. So Bahareh, thank you so much.
Of course.
Great job. That was really helpful.
Thank you so much.
All right. Have a good one.
You too. Bye. Bye, everyone.